All right, hi. Here's a lab I did with my class today. Yesterday we learned Le Chatelier's principles and the stresses we can apply to equilibrium systems. Today we took a look in the lab what that stress looks like. So our first system, we have a saturated solution of NaCl in equilibrium. We know that means at the rate the solid is breaking apart, making the ions are coming together to make the solid. So it's moving in both directions. So we're going to pour 5 mils of that into 2 test tubes, and then we're going to add in 10 drops of 11.7 moles per liter of HCl. And then we're also going to add in 10 drops of 1.0 moles per liter of HCl. So HCl in both just different concentrations, and see what happens. So I do have a video of this that I would like to show, and I hope it will. Yeah.
For B, do I have to bring up another tube?
No, that's at your station. But yeah, you do it in another test tube.
Wait, Miss Nash.
Yeah.
Is this supposed to turn into salt?
Yeah, you're making a salt. So coming back to what's actually happening in this experiment, so we added that HCl. What we want to remember is that HCl is a strong acid, and strong acids break into their ions. So we have H positive and Cl negative present. And then when we added it in, the first one, we hopefully can tell that we're adding directly Cl negative into the solution. So we're increasing Cl negative, and whenever you're adding in, you shift away. So this causes a shift to the left, which means you're making more NaCl solid. Now, with that 1.0 molarity, moles per liter of the HCl, we didn't see any change, but that doesn't mean it wasn't happening because we did add it in. It would just be a microscopic change. And when we added in the 11.7 moles per liter, we could see it. So that would be called a macroscopic change. So that was the first part.